Okay, so yesterday I think we discussed about the replace function, the all the transformations we have seen, right? So today I'll try to explain about the window functions or analytical functions. You can call it in any way. So how you are dealing it in SQL, in the same way we can deal it in PySpark as well. So sometimes we use this one as well in the real-time coding. Okay, you guys have to understand this. Okay, this is quite similar to like SQL only. Nothing difficult here. Whatever the concept you understood in SQL, same concept carry forwards here. That's it. Okay. So what are all the different analytical functions you know? Basically, like rank, dense rank, row number, and the some average, min, max, all those things are there, right? Lead, lag also, of course. Okay. So we'll try to understand the functionality one by one here. Okay, come on, help me. First one I'm trying to discuss about the rank. What rank does actually? Let's say I have data like this. This is one of the interview question, guys. Again, I'm just trying to discuss here. So I have the data like this: A, B, 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 C, D. So this is my data actually. I'm trying to apply the rank on top of this data. Now tell me, consider this is something ID or something. Okay. Now I wanted to find out the rank on top of this one. Now what you'll get here? What rank does actually? It basically all the analytical functions will assign some number. It's not random number, it's a sequence number. But based on the data, it will try to allocate the number. Okay. In the case of rank, what will happen? Rank will leave the holes, right? When I say holes, first, so it will try to partition the data, whatever the partition column you're trying to mention. So based on that partitioning, actually, it will try to check the data. So here it will try to assign 1. Since rank leaves the hole, 2 will not come here. So directly it will try to take 3. So since the next value is also same, it will try to assign 3 only. So for this one also, it will try to assign 3 only. Okay. 3 or 4? 3 only, right? Okay, and for C it is 4, and for this one, oh sorry, for C, oh sorry,
6.
sorry, sir, my bad. I think I'm doing it wrong. Now tell me, A 1 1 is correct here. Okay, and for here also in this group, this is 1 1 1 again, right? Not 3. Correct? Correct me if I'm wrong.
No, sure.
What
What you
I'm
are trying to do, sure?
rank.
Rank group by ID. You have given our
Okay,
normal rank
so
function.
let me not group the data here. Now tell me based on overall records. Okay. Now 1 1 uh
3,
3 3 3 4 5. Correct?
not 4. There it will.
Oh, okay. So it will miss this number, right? So
Five,
3
Yeah.
4
six.
5 6 you'll get right here. Sorry. And 7 you'll get. If you group the data, then the case is different.
Yeah.
Okay. Uh, anyway, so these kind of result you will get actually. So how we can achieve that one in SQL? First, I'll try to explain that one. Later, we'll try to see same thing in the PySpark. Okay. Let me erase this one. Where is this SQL part? This is the one. So I'll just try to copy the same thing and put it in another cell. Uh, so we need to create, I think, view, right? I think I've already created that. Let me try to execute it once again. And now, instead of dense rank, I'm just trying to take actually here rank. Okay. Now, see guys, in SQL, this is the case actually. Rank, we'll just open the close the parenthesis here over partition by some column. Okay, order by some column. That's what we need to mention here. Either ascending order or descending order, depending on your requirement. Okay, partitioning is not mandatory, but order by is mandatory, I guess. So if you want, you can mention that one, or you can skip this part. Okay, as rank, because rank in department, I'm just trying to give a alias name for this one from EMP table. EMP table is nothing but the view we have created right here. So I'm just trying to use that one here as a table. Now, if I execute this one, first it will try to group the data based on the department number. So, department number means all 10th departments it will try to take. It will try to sort the data based on the salary. Let me try to execute this one, try to understand the data, and later we'll try to understand this one. Okay, see here, within 10th department number, the salaries are completely different here. Not different. Some of the salaries are same here. So 5,000 we have here, 1 and 1 we are getting here. Okay, next salary is 4,000. That is the reason why 1 did not get repeated here. Directly we got 3 and 4 here. Okay. So in the 20th department number you take here, uh, what you're getting? Since the salary is 3,000, 3,000 is same here. I'm just getting here 1 and 1 because the data is partitioned right here, because you're saying that partition by department. Within that department, within that group, you try to assign that values. That's what the meaning of partitioning here. See, if you don't mention partition by here, it will try to group the data based on entire thing here, entire data, I can say. But you are saying that here within that group, what do you want to do? So this one we call it as within that group, in the sense we call it as a window. So that is the reason why we call these functions are windowing functions. This is one window and this is another window. Okay, and this is another window, like that. Okay, so within that group, what is that? How do you want to assign the value? That's what you need to understand here. Okay. So 113. Now you understood, right? 1134. Why we got that? That is the rank behavior. Rank will leave the holes actually. Skip the numbers, I can say, in your language. If you have same values, it will try to repeat the same values. And for the next value, it will simply skip that and give the next value here. Any questions around this in SQL? Okay. Okay, so same thing, how do we get it in Spark? Okay, so for that, we need to import the window function here from the SQL window module. Okay, I'm just trying to import that one. Okay, rank also from the SQL functions, we need to import it. We need to import it. See, how you are preparing this over partition by order by whatever you're mentioning here, that we need to prepare here first. You can take any variable name here. Window specification equal to window dot whatever we imported, that dot partition by, same thing whatever we are mentioning in SQL, same thing we need to mention here. Partition by what column we mentioned here? Department number, right? That is what I'm trying to partition by this one. But here we write everything in a same over class here, but we write here in a different way. Partition by separately, order by separately here. Partition by that column name, order by that column name. Order by that column name, either in descending order or ascending order, anything is okay. That depends on your requirement, I can say. First, we need to prepare this particular window, and after that, we need to mention that. Okay. See, since this is a new column here in this SQL expression, I wanted to, if I want to create a new column in the data frame, what is that I need to use? With column, right? With column, that column name. Okay, and rank, whatever we are using here, rank, same thing I'm trying to use here, dot over that window specification, whatever we created, right? That will simply mention it. That's it. Syntax here and there, little bit change here, but the concept is same here. Okay, if I execute this one, let me try to erase all the outputs here.
Window specification means we are making into group. We are telling to make them separate groups.
Uh-huh. How you are mentioning the grouping in the SQL, and the same way we do that one here. Okay, where is that? Oh, I think 2 times I copy pasted. Okay. So this is the one actually I'm just trying to talk. Yeah, see? So same output you got here and here. Oh, where is that one? I think I did not execute this one. See, same output you got here and here. 1134, 1134. See, syntax is little bit changing. That's it here. But rest all, the concept remains same, right here? See, last two values are 1, 1. Here also we got 1, 1 here. Anything difficulty here? Nothing. We just need to prepare this particular statement. That's it. We have to use that one here. The rest all same. Clear?
Yeah.
Okay. Yeah. Moving on to the next one. So sometimes, I don't know how many of you observed, even in SQL also, you could have observed here rows between window dot unbounded preceding window dot current row is there, right? Okay. You would have seen this kind of syntax somewhere. Okay. What do you mean by that one? See, same thing I'm trying to do. Window specification multiple. I mean, I'll tell you why did I take it as multiple. Window dot partition by department number, order by salary, descending dot rows between this one I'm trying to take. See, even if you mention or if you don't mention, the concept is same, but so, there is some difference here. I'll talk about that one. Okay. Okay. Yeah, sorry. So there is some difference here. I'll talk about that one. So the meaning of this one is you're already partitioning the data in the table based on the department number and you're allocating that numbering, right? 1, 2, 3, 4 or 1, 1, 3, 4, whatever number you're doing it. Within that, if you want to do any subgrouping, right, then we have to use this one. This is the default subgrouping, I can say. What do you mean by that is rows between window dot unbounded preceding. That means it has to start from the first row to the next row, current row to next row. That's what the meaning of this one. See, if you want to know more about this one, I'll just ask like Perplexity here to explain this one so that it gives the clear explanation. Explain this in PySpark or SQL. Okay. It will give an example so that based on that example, I'll try to explain here more. See here. Window dot unproceeding means marks the earliest row in the partition. First row in that partition. Or current row reference is the row being processed. Okay. So first let me try to execute this one and see what is the output you're getting. Based on that, I'll try to come back here and explain that. Okay. Now let me go here. Where is that? Where did I execute this one? This is the one, right? Now let me execute this one. See, so you're not getting any difference here. So instead of that, what we have to do is either you have to mention 1 or 2 or 3. That's what you need to mention. Okay, let's say I'm trying to mention 2 here. Now see the output what you're getting here. So if at all, if you really wanted to observe the difference, right, you can observe this difference only in the sum operation, sum or average, min, max one actually. Mainly in the sum we use this one, not in the rank and dense rank and all. Okay, but I'll try to explain here and see what is the output you're getting here. Match the required frame specification window, unbounding, current row. Uh, we can mention the number here. Okay, let me previous row. That's what we get here. Uh, we can mention the numbering also here. That's what I'm trying to check here. Uh, Okay, when I go to like sum, right, I'll try to explain that one again. Okay, so for now you just try to understand that it will try to compare the first row and the next row. Okay, let me explain. Okay, so here it will try to compare the first row and the next row. because the current row I'm trying to tell right here. So it will try to compare with the same row only here. Okay. It will start with the first row and it will try to compare with the current row only. That is the reason why it is giving 1 here. Okay. So I'll try to explain more about this one in the sum operation. You'll understand more yeah, easy way there. Okay. So in the rank and dense rank, it doesn't create any difference. That's what I'm trying to say here. Okay. For now, you just mentioned this is the default behavior. Whether you mention it or not, it is just a default one actually. It will try to compare the current row wherever you're starting that with the same record. Okay. So same output you're getting as earlier because this is the default one. Even if you don't mention this one, it behaves in the same way. Okay. So coming to the next one, that is dense rank. Now tell me what is the main difference between the rank and dense rank. So in the case of rank, actually, what did we do? Let me write here same thing. A, B, 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 C, D. This is what I'm taking here. Okay. And E also I'm taking. So for the rank, what is the output you'll get? Come on, help me. For the dense rank, what is the output you'll get? Dense rank. Now come on, help me here. I mean, whatever you know in SQL, just tell me that. Rank, you guys already know. One, one. I mean, overall, I'm trying to do here. Okay. So three, 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 four, five, six, seven, eight. This is the output. Now come on, in the dense rank, what you'll get? One, one, two, 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 three, four, five. That's it. This is the output you'll get. See, now based on this output, you just tell me what is the difference between rank and dense rank. This is one of the interview question again.
There will be no increments in the dense rank.
No increments means like
Rank number 113.
it doesn't leave the holes or it doesn't skip the numbers.
Yeah.
That's what we have to understand here. Okay. So same output you can expect here. I'm just trying to partition the data based on the department number and order by salary in the descending order here. Now let's see what is the output you'll get. Okay. Same behavior you need to understand. See, even when you go to interview, you need to remember this kind of pattern so that always remember one thing, rank leaves the holes. That is only the statement I remember always. Remaining all are very easy. Okay. So let me erase this one and let me try to execute the same thing here. In SQL, I'm trying to execute that first and later I'll explain about, see here, the 10th department number for the same salary, you're getting 1 and 1. For the different salary, you're getting 2 and 3 here. It's not skipping the numbers here. But in the case of rank, what you're getting here, 1, 1, 1, 1, and it is skipping the number and it is giving the next number as 3, right? But in this case, what is happening? 2, 3 we are getting here. Because we are partitioning the data here. In my previous example, the one I have drawn here, I'm not partitioning any data. I'm trying to look at the data at the overall data level. That is the reason I'm just trying to take like that. Okay, because you're mentioning here partition by that is the reason it will look only for the at this group level, at this window level. And even for the next one, you try to see here, 1, 1, 2, 3, 4. It's not skipping any numbers here. And next one also you try to see 30th department number, 1, 2, 3, 4, 4 we are getting because these two guys having same salary. Of course, the 5 also. Next two guys actually having same salary, so we got 1, 1 here. That's it. Okay. Now row number. Now tell me what does row number do here? For the same example, you try to tell me. If I take A, B, 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 C. Oh, 1 second.
Shiva, have you executed dense rank in Spark?
Yeah. Oh, did I not? Okay, one second. Let me tell you. Let me execute that one. Same thing only. Just you need to change here in place of rank. You just need to put dense rank here. That's it. Same output you see in SQL and PySpark. You're getting the same output here. In place of rank, you just need to change it to dense rank here. That's it. Nothing will change except this one. Rest all same. Oh, now next row number. Come on, help me with this row number. I'll try to take the same example. A, A, B, 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 C, D. This is my data set actually. Now tell me, for rank, dense rank, row number, RN I'm taking here. Okay. Now what are the outputs you're getting here? 1, 1, 2, sorry, 3, 3, 3, 4, sorry, not 4, 3, 4, 5, 6 here, right? 6, 7. And dense rank 1, 1, 2, 2, 2, 3, 4. This is what I get. Row number hmm.
1, 2, 3,
1, 2, 3,
2, 3,
4,
4,
5, 6, 7.
6 equal.
Is it correct? Is it correct?
Yes.
It will give continuous number. That's it.
Yes.
It will simply give the continuous number. Okay, let's see the output is same or not here. Okay, I'm just erasing this one. You need to remember this one, guys, so that you can able to answer any question easily in the interview. Okay, now let me remove this. Okay, now let me execute the same thing in SQL first. See, you're getting in within this group. Group level, you need to think here. 1, 2, 3 continuous number you're getting or not? I think partition by I did not mention here. That is the reason why group level you are not getting here. So if I remove that partition by, see, it is looking at the overall data here and it is assigning the continuous number here. See, irrespective of the duplicates. If you mention partition by here, definitely the output will change. Where is that? Okay, partition by I'll try to mention here. So partition by department number. If I execute this one, now see, the things will change here. So within this group, continuous number 1, 2, 3, 4. Within this group, continuous number 1, 2, 3, 4. Within this group, continuous number here up to here, right? Within this group, continuous numbers. Irrespective of the duplicates, it will try to assign the continuous numbers to the values. That's it. So this will be useful mostly in the in duplicates removal in SQL, right? That's what we use, right? Mostly, correct or not?
Mm.
Row number we use mostly for deleting the duplicates. Rank and unrank also we can use, guys, but logic is little different. That's it. Okay. That is about row number. Oh, let me execute that row number. You just need to mention here window row number. That's it. Sorry, this is column name, and here row number of that one we need to mention here. This is just a column name. Okay. See, you're getting the same output. Whatever I have here, same thing I'm getting here. Clear?
How frequently we use these window functions?
Depending on the requirement, I can say in last 3, 4 months, I did not use them, to be frank. Okay, so I think I don't know when did I use it last time. I did not remember it. Maybe 6 months back, I could have used it. Okay, so one simple example I'm just trying to take here to just understand the difference between the rank, dense rank, and the row number. So these are the scores of the employees or students: 90, 90, 85, 85, 78. Now, if you write rank right, what you'll get here? Rank leaves the holes, right? 1, 1, 3, 3, 5 you're getting. If you have duplicate, the number will be repeated here. And dense rank 1, 1, it will not leave the holes. 2, 2 we are getting. 3 I'm getting. Row number, it will give the continuous numbers here. This is what I was telling you. Okay. Hmm. Now, sum, min, max, I'm taking here. If I take the sum, okay, sum is also sum we have normal aggregation function and the analytical function. Both I have, guys. Both I have. Okay. So here we can mention same thing like your regular rank, dense rank only. Window dot partition by the department number here. Okay. Order by is not required because you're anyway doing the sum without irrespective of the order, right? So order by is not required here. So with column of department wise sum I wanted to calculate here. So for that sum of salary I'm just for the rank, dense rank, and the row number, it doesn't take any column name as input, but sum actually takes the on what column you wanted to perform that sum operation, salary column. So our window specification dot so that's what I'm just trying to execute here, and see what is that output you're getting here. Based on the output, you need to give me the conclusion. Now tell me. Uh, I'm just trying to partition the data based on the department number, guys. For the 10th department data, I got here 15,300. Ah, what is that you're getting? Why did we get like 15,300 here? How it is related to the data? Sum of salary per the department, right? So it will try
Yeah,
to sum all these values, right? 5,000 plus 5,000 plus 1,300 plus 4,000. What is that sum you'll get? 15,300
15,000.
only. Okay, so in the 20th department data, you'll get like this. 30th department data, you'll get like this. Okay, in last one, you'll get like this. Okay. Same way, average, min, and max, if I take here, same thing you'll get actually. Now let me try to take this one. Average per department, sum of salary per department, minimum salary from the department, maximum salary from the department. Okay, you can add any number of columns like this. Okay, so this is about sum, average, min, max. See, if you understand one window function, other functions are similar to that one. Only small changes you have to do to that. Okay, clear? So if at all, if you want to find out what I can say, cumulative sum or running total, sometimes you may get this question. Maybe they did not ask anytime in the PySpark, but they've asked the same question in the SQL. How do you calculate the running total in SQL? Okay. So this is what we need to do for that. Same thing, whatever I've taken here, I'm just trying to take here. Previously, whatever I've taken, I'm trying to take this one. But here, rows between window dot unbound preceding. I told you, right? We can mention the number also here. I told you already. Okay, 1, 2, 3, 4 also you can mention. Okay, so if I mention 0, what is that output you'll get? That's what I'm trying to uh, check here. Okay, now let me execute this one. Now see. Now see the salary. See what is happening here. Oh, come on. What is
It,
happening here? First
it,
row,
it
1300 as it is we are getting. The second row, you're getting actually 5300. Where did I get this 5300?
it adding.
So 4000 plus 1300, 5300. See, cumulative. See, it is just trying to add the previous record value, right? This is what we call it as a like a running total, right?
Yeah.
Correct or not? So I can achieve this one easily with the help of this particular option. Okay, you understand, try to understand here. So third record like 5300 plus 5000, 10,300. Fourth record, I am trying to get like here 10,300 plus 800. Oh, sorry, within this group only, right? So we got the values like this. So if you take the second group here, first record as is I got here, as is. Okay, second record 800 plus 1100. So 1900, 1900 plus 2975, 4875, 4875 plus 3000, you'll get this one and next this one. This is what we call it as a cumulative sum. Previous output value, we're just adding it to the next one. That's it. Okay, what if we take one here? Let's try to understand that. See, you're getting output. This is what I was telling you. The rank, you don't get the proper output, but in the sum, we can get it definitely. Now tell me what is happening here within this group. Same output you're getting, huh? Same output you're getting, right? Any difference between this one and this one?
Yes. First record is not.
First record is not getting properly, right? Try to observe the difference here. So first one itself is 5300, right? When you say one here, okay, it will try to look for the previous record. Previous record. I mean, unbound preceding and rows between one. That means next record it will try to consider. Next record, following record. One means following record. So the sum it will try to take current record and the following record as well. 4000 plus 1300, 5300 you're getting. Okay, so you're grouping the data within that boundary, I'm trying to say. Okay, now rows between, we are trying to perform the sum operation between these rows. Okay, now the next one is actually 4000 plus what is that you got previously, the overall sum 5300, right? That is what I got here. 5300 plus 4000, 10,300. And next one, if you try to add 15,300, you'll get. So since the values are repeated here, you're getting same value here as well. Get it? So if you take 2, it will change here. Next 2 rows, it will take here. See? What is that you got? First row? This value plus this value plus this value. Current row plus next 2 rows. That's what the meaning of this. If you simply take 0 here, it will try to consider the current row only. Okay. So that is about cumulative sum. Lead lag is little bit different than the other functions. Okay, so first let me execute here this one, the output, and based on that we'll try to understand. Similar to this one. So how you understood sum, right? Same way, but little different. Okay. So lag. Sorry. Lag. What is that output you're getting here? So first you take this record here. Lag of partition by department number, order by salary, same I'm taking here. The only change is lag function I'm trying to take here, comma 2, comma 0 I'll take it. Or otherwise I'll just simply, I can remove this one, I think. Okay, let me execute this one. Now see, we got the same thing here. Now, since I don't get anything, okay, lag means previous value, previous record value, it will try to take it. Okay, so for the first record, I don't have previous one. That is the reason why it is taking it as null. In the second record, actually, what is the previous record salary value? 1300, right? I got this one here. Lagging, one record value lagging here. So third one, if I take here, what is the previous value, previous record salary? 4,000. That's what I'm getting here. Like that, the one row is just behind here. That's it. So for the first row, since you do not have any like previous record to this one, we get null record, obviously, within that group. Even in the second group also, we got the same thing. Getting my point?
Yeah, sure.
Lead is also similar to that one. If at all, if you want to control how many values you have to move forward, then you can control from here, guys. Okay, now lead also I'm just trying to execute here. So lead, I'm just trying to remove this one here, 1,0. Now let me execute this one. Then lead means immediately next record it will try to take. See, in the case of lag, previous record it has taken, right? Now in the case of lead, next record it will try to. What is the next record value here? 4,000. Next one record value is 5,000, right? 5,000 we got here. Next record value is 5,000, 5,000 we got here. Like that, last value you'll get as null here. In the case of lead, first value you'll get as null here. Quite opposite to that one. That's it. This one will take the previous record value. This one will take the next record value. That's it. That is only the difference. Okay. See, you just need to understand only this particular formula, guys. Whatever I told you, right? In the rank, where is this one? Yeah. You just need to understand only this particular formula. That's it. If you remember this one, you're done. So based on this one, you'll get a lot of interview questions actually. They'll ask you to remove the duplicates. They'll ask you to find out the second highest salary. Like that, lot of questions you'll get. This topic is very, very important in SQL and even PySpark as well. Okay, so that's it about the analytical functions. So I have a hard stop here. I'll stop for today. Let's call it a day. Any questions?
So how to find the second highest salary in Spark?
You just try it from your end. If you're not able to get it, I'll try to explain in the next class.
What is
Okay.
option? How
Okay.
to
How to get the second highest salary in the department.
use row number function?
That's it. Yeah.
Okay.
You tried.
1, 2,
Not
second
row
one is
number
the
is not
second
required. Row
highest.
number is not required.
I
You
mean,
can take the
one of the rank.
rank or dense rank. You can take. Dense rank is the best one actually to find out that. What if the two employees having the same salary? Okay, the dense rank is the best one to identify that. Okay. Try that one your end, Venu. If you're not getting, I'll definitely explain that one. It's very easy
Sure.
only.
Yeah,
We'll
sure.
just put where condition on top of this one. That's it. Where this one greater than 2. I mean, second highest salary means equal to 2 will mention. That's it.
Yeah, we'll try.
You try that one. It's very easy. Okay. Let me stop recording the session.